Hello everyone, now we're going to talk about integers. Integers are really just your counting numbers, just like 1, 2, 3, 4, 5, but they do include 0 and your negative numbers. So if you've ever lived in a place that is really cold, like on this page, they're showing you the thermometer, then you know that your temperatures can actually go below 0. Just like your checking account has the ability to go below 0 and deal with negative numbers. So that's why we need to have numbers to represent those things that are actually below 0. So on a number line, you can see here that your positive numbers are over here. Your negative numbers are over there. And notice that they go in the opposite direction. So on the positive side, they count up and they get bigger. On the negative side, they count down and they get smaller, actually. If you are asked to plot a number on a number line, then all you have to do is put a dot wherever that number occurs. So where is positive 3? And notice we don't put a plus in front of 3 to indicate positive 3. We just put the number 3. But for negative numbers, you have to put that minus sign in front of the number to indicate negative. So going back to this, plotting these numbers on the number line, I'm going to just put a dot at the number 3. For this one, I'm going to put a dot at negative 3. I don't know what just happened there. There we go. And for the last one, I'm going to put a dot at negative 2. That's it. We just plotted those numbers on the number line. That's all you have to do for that. Okay, so positive numbers, I just said earlier, they're increasing as you go to the right. Negative numbers are decreasing or getting smaller as you go to the left. And how far out does this number line go? Well, the arrow right here indicates that it goes on and on forever in the positive direction, and over here this indicates that it goes on and on forever in the negative direction. Okay, so if we are using less than, remember this symbol is less than, and this symbol is greater than. So if we are ordering these, then the thing that you need to remember is that your bigger numbers are on the right. So notice every one of these numbers that are over here on the left have a corresponding dot somewhere on this number line. So right now on part A, we're looking at 14, which is right there, and we're looking at 6, which is right there. The number on the right is your bigger number. So this would have that symbol right there. 14 is bigger than 6. Okay, so let's take a look at negative 1 and 9. Negative 1 is right here. Positive 9 is right here. Always, 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 your positive numbers are bigger than your negative numbers. So in this case, we would put this symbol because 9 is greater than negative 1, or you could say negative 1 is less than 9. All right, on this next one, we've got two negative numbers. We've got negative 1, which is right here. We've got negative 4, which is right here. Now, what I've been telling you is that the greater numbers are on the right. That is still correct. So you want to think about it this way. If that doesn't make much sense to you, think about it this way. What would you rather your checking account be? Would you rather it be negative 1 or negative $4? And so the negatives mean you owe the bank money. So you'd rather only owe the bank $1 than $4. So negative 1 is greater than negative 4. And again, negative 1 is on the right of negative 4 on the number line. Okay, so let's take a look at 2 and negative 20 Here is 2, and here is negative 20. They're kind of far away from each other on this number line, but still, positive 2 is greater than negative 20. Even though 20 is a big number, it's still in the negative section. So 2 is greater than negative 20. Okay, to find the opposite of a number, you are really just looking for the same number but with the different sign. So if you have a negative number, you're looking for a positive. If you have a positive number, you're looking for a negative. And so you're looking for that number that has the same distance from 0 on the number line, but on the other side of 0. So the opposite of 7 is simply just negative 7. The opposite of negative 10 is just positive 10. That's it. You're done. You don't have to do anything else to that. Okay, so I know that a lot of times we use the term negative whenever we say like negative 7, but really also what the negative sign means is the opposite of positive 7. So it's just another way to use the words. It's not really anything major. It's just you could use the word opposite of 7 or you could say negative 7. They are one and the same. Okay, so like I said earlier, integers are your counting numbers. Also, it includes their opposites, so the negative numbers, and it also includes 0. Okay, so now we're going to evaluate the opposite of x. So on part A, whenever we say x is 8, we want the opposite of 8, so our answer would be negative 8 on part A. On part B, the opposite of x, and in this case x is negative 8, so I want the opposite of that, so the answer would be positive 8. Okay, whenever I talk to you about the absolute value of a number, all I am asking you for is how far is that number from 0? So on part A, it's those bars, those vertical bars, they're not brackets, they are truly just vertical bars, mean what is the distance. So it's absolute value. Those are absolute value bars. So distance that a number is from 0. So on part A, how far is 3 from 0? It is 3 units. That's your answer. So on part B, remember, distance can never be negative. Even if you walked backwards somewhere, you still walked however far you went. You don't indicate that with a negative number because you were going backwards. Distance is always positive. So the absolute value of negative 44 is positive 44. And on part C, how far is 0 from 0? It is simply just 0 units away. Okay, so in these, we're evaluating absolute values. And in part A, when x is negative 35, so we are evaluating the absolute value of negative 35. What is the absolute value of negative 35? Well, how far is negative 35 from 0? It is 35 units away. That's your answer. Okay, so let's take a look at absolute value of negative y when y is negative 20. So check this out. In the problem, I have a negative sign, but what I'm substituting in also has a negative sign. Not that it really matters because those negative signs are going to go away anyway because they're inside the absolute value bars. So the absolute value of positive 20 is just 20. Okay, on part C, this one's a little bit different. We've got the negative sign occurs on the outside of the absolute value bars. So what that means is, on this problem, I'm going to substitute 12 in for u. So what you want to do, take the absolute value of 12, which is just 12, and then you have to multiply it by the negative that's on the outside. So in this case, the answer is negative 12. It's the only time that you're going to see absolute value turn into a negative number is when that negative sign is on the outside of the absolute value bars. Okay, and on this last one, notice you have a negative sign on the absolute, or on the outside of the absolute value bars again. So we've got negative, and what I'm going to replace for P is negative 14. So you have to take the absolute value of negative 14 first, which is positive 14, then multiply it by that negative on the outside, so you get an answer of negative 14 here. Okay, on these problems, we have to evaluate the absolute value first, and then we have to compare the numbers. So on part A, I have the absolute value of negative 5, which is simply just positive 5. On the right side, I've got the absolute value of negative 5, which is 5, but I have a negative on the outside, so this number is negative 5 right here. So I'm comparing 5 to negative 5, and always your positive numbers are greater than your negative numbers. On the next problem, I've got 8, and then on the right side, I've got the absolute value of negative 8, which is positive 8, but then I've got the negative on the outside, so that gives me negative 8 over here. So I'm comparing positive 8 to negative 8. Positive 8 is definitely greater than negative 8. Okay, on part C, I don't take the absolute value of this one. Notice it doesn't have the bars on the left-hand side, so I'm just left with negative 9. And on the right side, I've got the absolute value of negative 9, which is positive 9, but then I've got the negative on the outside, so that gives me an answer of negative 9 on the right. So those guys are equal to each other. On part D, I've got the absolute value of negative 7, but then I've got the negative on the outside, so that gives me negative 7 and negative 7. So that gives me an answer of they're equal to each other. Okay, on these problems, absolute value bars are also considered grouping symbols. So you do what's inside the absolute value bars first before you take the absolute value. So on part A, we would do 9 minus 3, which is 6. So we're going to take the absolute value of 6, which is just 6. On part B, you are multiplying here. Anytime you have a number that's touching a grouping symbol, that operation indicates multiplication. So we're actually multiplying 4 times the absolute value of negative 2. So it would be 4 times the absolute value of negative 2, which is positive 2. So our answer here would be 8. Alright, on this problem, again, absolute value bars are grouping symbols, so you have to do what's inside the grouping symbol first, according to the order of operations. So on the left side, we have the absolute value of 15. Notice the minus sign right there. And then you want to take the absolute value of 5 plus 6. 5 plus 6 is 11. So we're actually doing the absolute value of 15 is 15, minus the absolute value of 11 is 11. 15 minus 11 is 4. That's our answer. Okay, right here, again, absolute value bars are grouping symbols, but notice you have grouping symbols inside those grouping symbols. So you always want to do your innermost grouping symbols first. I'm not touching the 24, I'm just rewriting it. And I'm rewriting everything else up to those innermost grouping symbols right there. 19 minus 6 minus 2 is, oh, I forgot my 3. 3 times 6 minus 2. That's what I want, right there. Now I need to multiply the 3 times the 4. So I've got 24 on the outside. 19 minus 3 times 4 is 12. Now I want to do what's inside the absolute value bars, because remember, order of operations says you have to do the grouping symbols first, and absolute value bars are grouping symbols. 19 minus 12 is 7. So now I want to take the absolute value of 7, so I've got 24 minus 7, and 24 minus 7 is 17. That's my final answer. Alright, on these we are translating the phrase into an expression with integers. So on A, we want the opposite of positive 14. The opposite of positive 14 is negative 14. On part B, we want the opposite of negative 11. The opposite of negative 11 is positive 11. On part C, they're not asking you for opposites or anything like that. They're just asking you to write the term negative 16 in numbers. And on part D, 2 minus negative 7. I really hate to see things written like this, 2 minus negative 7. It seems messy, so I really do prefer to put parentheses around that. That way you don't have two minus signs right next to each other like that. This way it just looks a little bit cleaner. Okay, so on this one we're translating into expressions with integers. So the temperature is 12 degrees Fahrenheit below 0. So we would say that if it's below 0, it's going to be negative. So we would say it's negative 12 degrees. And you could even put the little degree symbol, and you could put the little F if you want. But that's negative 12 degrees Fahrenheit below 0. On part B, we're looking at a gain of 3 yards. If you want to put plus 3, that's fine, or you could just put simply 3. The elevation of the Dead Sea is 1,302 feet below sea level. Below sea level means negative, so we would say negative 1302 here. On part D, checking account is overdrawn by $40. Overdrawn means that you're in the negative, so you would say negative 40 here.